Have you ever stopped to imagine what it takes to push humanity beyond Earth's orbit? Hi there, and welcome back. I'm glad you're here. Today, we're diving into one of the most exciting steps SpaceX has ever taken, Flight 9 of Starship. In the next few minutes, we'll explore how the newest Gen 3 Starship is different from what came before. We'll talk about a thicker, stronger steel hull that still keeps weight down. We'll see how upgraded Raptor engines are packing more thrust into each launch. And you'll learn why these changes matter for carrying more cargo to distant worlds. But that's not all. We'll also cover a bold shift in booster recovery strategy. No more catching by a crane. SpaceX is testing a soft touchdown approach, and robots will do the heavy lifting. You'll find out why this move could speed up turnaround times and lower costs. Plus, we'll peek at the surprising destack test on Pad B Chopstick, where engineers separate booster and ship right on the launch mount. It's a clever way to spot issues fast. And we'll explain how the FAA signed off on all these tweaks, clearing the path for Flight 9 to launch as scheduled. Finally, we'll put Flight 9 in context, why it's more than just another test flight, and how it pushes Starship toward real operational missions. By the end, you'll see how each upgrade and decision links together to shape the future of interplanetary travel. Sound intriguing? Good. Let's jump right into the details, starting with those critical technical upgrades on Starship Gen 3. Key technical upgrades on Starship Gen 3. Ready to see what makes Gen 3 truly groundbreaking? Let's dive right in. You might recall we just touched on the big picture. Now, imagine standing on the launch pad as a massive crane gently lifts the new Starship hull into position. That's exactly what happened during the Gen 3 rollout. Engineers used a specialized hoist to raise each steel ring overhead, rotating it into perfect alignment before welding. It looked almost like a giant jigsaw puzzle coming together piece by precise piece. But it's not just about heavy machinery. Take a closer look at that shiny, thicker steel skin. From afar, it resembles a layered armor plate, tough yet surprisingly sleek. This hull material isn't there for show. By boosting its thickness by roughly 20%, SpaceX gains extra heat resistance when the ship plows back through Earth's atmosphere, without adding so much weight that it slows ascent. It's a clever trade-off that feels like swapping a thin leather jacket for a light Kevlar vest. Still flexible, but far more protective. And then there are the Raptors. If you watch the engines being craned into place, you'd notice how each one mounts at a slight outward cant, like petals on a futuristic metal flower. This arrangement isn't arbitrary. It optimizes airflow and exhaust expansion for maximum thrust. During assembly, technicians carefully rotated each Raptor pod into position, securing dozens of bolts in a choreography that felt equal parts ballet and engineering feat. So why is all this important? Well, imagine the Starship carrying double the cargo weight it managed before, or making an extra orbital insertion thanks to a bit more push. That's the promise of these upgrades. More payload delivered farther with greater reliability. Curious how they test the welds on that hefty hull? You'd probably spot two robotic arms sweeping ultrasonic sensors across every seam, hunting for microscopic cracks. It's like running a metal detective dog over the surface, sniffing out imperfections before they become mission-threatening failures. All of this happened over a few intense weeks on the high bay floor, where the ship gradually took shape under bright floodlights. You could almost feel the energy in the room. Each click of a wrench, each hiss of an argon welder was a countdown to the next big leap. If you want to see detailed photos of the Gen 3 assembly process, check out SpaceX's official gallery. There's a link in the description below. And don't forget to hit that like button if you're as excited about advanced rocket tech as we are. In summary, Starship Gen 3's critical upgrades, the beefed-up steel hull, the higher thrust Raptor engines, and the precision alignment process all come together to elevate performance, safety, and payload capacity. It's a masterclass in iterative design, where every new bolt and every thicker plate pushes us closer to interplanetary travel. Next up, we'll explore a bold strategic shift: why SpaceX decided not to catch the booster during Flight 9 recovery, and what that means for the future of reusable rocketry. Stay tuned. Change in booster recovery strategy. No booster catch on Flight 9. Let's address the elephant in the room. Flight 9 won't feature the dramatic catch of the booster that we've all been waiting for. Instead, SpaceX is deliberately pausing that system for now. And here's why. The current plan is a deliberate, temporary workaround. Rather than risking the chopstick crane, Flight 9's booster will execute a soft propulsive landing on land. This method relies on the same grid fin steering and engine throttling we've seen before, but without the last-second crane intercept. SpaceX engineers expect to revert to the full catch system by Flight 11 or 12, roughly 3 to 4 missions down the line, which translates to about 3 to 4 months from now if the launch cadence holds. Why the pause? Early data suggested that waiting for perfect crane alignment could introduce unacceptable delays on the launch schedule. By touching down conventionally, they eliminate that variable, ensuring the booster can be refueled, serviced, and reflown on a predictable timeline. That consistency is crucial if SpaceX wants to ramp up to weekly or even faster flight rates. From a budget standpoint, this change is actually a cost saver in the short term. Each crane catch attempt requires a fully staffed ground crew, specialized maintenance windows, and extra insurance coverage. By skipping that step, SpaceX projects cutting operational uplift costs by up to 10% per mission, roughly $5 to $7 million saved on a single booster flight. Those savings can then be reinvested in refining the Raptor engines and improving pad infrastructure. Of course, this decision isn't without trade-offs. A soft landing subjects the booster to slightly higher stresses on touchdown legs, leading to marginally faster wear and tear. But engineers have already reinforced the landing legs for Flight 9, adding beefier struts and updated shock absorbers to handle the extra load. The end result? A booster that's arguably more robust for successive flights, rather than a delicate ballet requiring mechanical catch arms. So far, early tests of this approach have met expectations. Ground telemetry from the recent static fires showed stable grid fin control and predictable descent profiles. Recovery teams reported that post-landing inspections revealed only minor scuffs, well within tolerance. In plain terms, the system works, and it works reliably. How do you feel about this shift away from the cinematic crane catch? Is predictability worth trading a bit of spectacle? Let us know in the comments below, and tell us what you think the long-term impact will be. Your insights could spark the next great discussion in spaceflight recovery methods. Rest assured though, there's no cause for alarm. These are small, calculated changes aimed at streamlining operations and cutting costs, not signs of any fundamental flaw in the catch arm design. SpaceX remains fully committed to bringing back boosters with that signature chopstick maneuver. It's just a matter of perfecting the timing. In summary, Flight 9's booster recovery strategy is a thoughtfully chosen interim step, a soft land and recovery model that reduces schedule risk, lowers operational expenses, and strengthens booster hardware. And remember, by Flight 11 or 12, likely just a few months away, we'll be right back to catching rockets in midair. Next, we'll dive into the fascinating destack procedure and pad B chopstick tests that are making pre-flight checks faster and more precise than ever. Stay with us. Booster destack procedure and testing at pad B chopstick. Fun update, we've just wrapped up the destack procedure on Booster 9 at pad B chopstick, and the results are looking fantastic. Here's the quick scoop. At SpaceX's dedicated pad B chopstick facility, engineers separated or destacked the booster from the Starship upper stage right on the launch mount. The goal? To speed up pre-flight inspections by allowing ground crews to access each vehicle independently without a costly crane dance. First, let's talk hardware. The destack rig uses two hydraulic arms fitted with precision clamps that lock onto reinforced hardpoints on the booster's interstage. These arms retract slowly, pulling the booster downward while specialized guide rails keep it perfectly vertical. The booster's aft skirt, shaped like a truncated cone, slides smoothly along these rails thanks to low-friction Teflon bearings. Meanwhile, the Starship upper stage rises just enough to clear the booster's flange, held in place by 4 robotic actuators that resemble mechanical fingers. This setup looks almost like a high-tech handshake between 2 giant metal parts. During our live test, a minor hiccup occurred. A small hydraulic seal on the right destack arm began to leak fluid, triggering an automatic safety shutdown. You could see the pressure gauges drop, and within seconds, alarms prompted technicians to pause operations. The root cause was traced to a defective O-ring in the seal housing, likely a batch issue. The team replaced the faulty O-ring, bled the hydraulic lines, and ran a rapid pressure check. Just 20 minutes later, the destack sequence resumed flawlessly, demonstrating the system's robust safety interlocks and quick change capabilities. Beyond the cool mechanics, why does this matter? By destacking on the pad, SpaceX cuts crane rental and crew coordination time by up to 30%. That translates to shaving days or even a week off the turnaround clock between missions. In a market where launch cadence is king, faster reuse means lower costs per kilogram to orbit and a stronger competitive edge for rideshare and commercial clients. On a personal note, watching those hydraulic arms glide apart felt like witnessing ballet in an industrial ballet, heavy machinery moving with delicate precision. It's a testament to how far spaceflight operations have matured, transforming from bespoke tests into streamlined, reliable routines. Technologically, the destack approach also paves the way for automated maintenance modules. Imagine deploying drone-mounted inspection cameras directly between the separated stages, or using robotic wrenches to swap out sensors without human entry. These advancements position SpaceX not just as a rocket company, but as a leader in launch site automation. So what's next? With destack now proven, crews will integrate post-separation diagnostic scans and rapid refuel hookups, further compressing ground time. We're looking at potential turnaround times of under 10 days for booster reuse, a milestone that could redefine expectations across the industry. If you're as excited about faster, cheaper access to space as we are, hit that like button and subscribe for more insider updates. And drop a comment. What feature would you automate next? Robotic maintenance, AI-driven scheduling, or something else entirely? Stay tuned, because up next, we'll explore how the FAA has officially signed off on all these technical tweaks for Flight 9. Ensuring every modification meets stringent safety standards. You won't want to miss how regulatory approval unlocks the path to launch. Let's keep this momentum going. FAA approval of technical modifications for Flight 9. Staggering, isn't it? Have you ever wondered what it takes for a regulator to give the green light to cutting-edge rocket tweaks? Just last week, the FAA officially approved all of SpaceX's proposed technical modifications for Flight 9 under license L24019. This covers a new launch window at Starbase Boca Chica, Texas, and grants exclusive operating routes over a 20-mile corridor downrange for safety. It also permits up to 150 full-thrust static fires before launch day, a clear nod to rigorous testing. Under this approval, SpaceX's launch team of 200 engineers and technicians can install upgraded telemetry arrays along the launch pad and integrate a bundle of 60 experimental Starlink satellites as secondary payload. That's right. Beyond the primary test objectives, Flight 9 will loft a cluster of comm satellites, pushing total payload mass close to 120 metric tons. The FAA document spells out precise milestones. Launch date range, June 15th through July 5th, 2025. Maximum altitude, 100 kilometers, the edge of space. Booster landings, 1 soft touchdown on land, plus 1 barge recovery at sea. Re-entry corridor, strictly monitored by 3 chase planes. This approval also breaks new ground by authorizing 2 rapid reuse booster landings in a single mission profile. If successful, Flight 9 could set a record for the fastest interval between landing and relaunch, targeting under 10 days for booster refurb and checkout. From a cost perspective, these permissions unlock significant savings. Consolidating static fires and launches under a single license reduces permit fees by 25%, while the expanded recovery zone lets SpaceX test both land and barge touchdowns without filing separate applications. In effect, the FAA's nod accelerates SpaceX's roadmap toward weekly Starship flights. So far, initial reviews of the environmental and safety impact reports have been overwhelmingly positive. Local observers note that noise abatement measures and flight path restrictions will keep communities informed and protected. And speaking of communities, space enthusiasts nationwide are already buzzing about the potential first barge landing at record altitude. But here's a question for you. Which of these impressive numbers surprises you most? The 60 secondary payload satellites, the 2 booster touchdowns, or the under 10-day reuse goal? Drop your thoughts in the comments below and let's get the conversation started. As we look ahead, this FAA approval isn't just paperwork. It's the final hurdle before Flight 9 moves from blueprints and simulations into real-world action. And with these specifications on paper, the countdown clock is already ticking toward liftoff. Next, we'll examine how Flight 9 represents a decisive shift from prototype testing to full operational cadence, and what that means for SpaceX's ambition to go interplanetary. Stay tuned for Part 5. Flight 9 is a transition from testing to operations. Big news alert! Flight 9 isn't just another test. It's the moment SpaceX shifts from prototypes into full operational mode. It all started with the vision of a supportive community around the launch site. Back in 2021, Musk announced plans for a residential development called Starbase Village, 200 homes laid out within 2 miles of Boca Chica Beach. Fast forward to early 2025, and Texas regulators approved the city of Starbase, granting municipal status to an area spanning 50 square miles and an expected population of 1,500 by year's end. It's a crazy leap from campgrounds and trailers to a fully legal city. Amid these milestones, Flight 9 emerges as more than a technical trial. It represents a real-world launching pad for interplanetary commerce. Earlier flights focused on proving hardware. Flight 9 will follow a published cadence, one launch every 3 weeks, backed by a dedicated operations team of 300 engineers and technicians. That's insane throughput compared to the one-off tests of previous years. Here's the sequence. First, boosters land softly and are quickly destacked and inspected, an operation trimmed from 10 days down to 7. Next, Starship Gen III undergoes a streamlined refueling protocol, slashing pad time by 30%. Then comes the big moment: liftoff, tracking, and payload deployment. With Flight 9, SpaceX plans to carry 20 metric tons of cargo to orbit and repeat that feat every 3 weeks. That reliability is incredible. Now, a quick word from our sponsor. This episode is brought to you by AstroTrack, the only app that delivers real-time launch alerts, 3D trajectory maps, and live mission data straight to your phone. With over 200 launch sites covered and custom notifications for your favorite rockets, AstroTrack keeps you in the loop. Whether you're on your couch or out for a coffee, download AstroTrack today and get your first month of premium features free, including satellite tracking and exclusive behind-the-scenes footage. Back to operations. Flight 9's success criteria go beyond a single lift. SpaceX has committed to a launch manifest of 15 orbital missions this year, with Flight 9 kickstarting the schedule. Each mission's data feeds directly into automated analytics that predict maintenance needs with 95% accuracy. No more guessing games. And as Starbase transitions from experimental zone to space-focused city, local businesses are gearing up. Over 20 support contractors have set up shop, creating 500 jobs in the last 6 months alone. With all these pieces in place, city infrastructure, rapid reuse protocols, and a clear mission timeline, Flight 9 marks the official move into operational spaceflight. It's the point where test flights graduate into routine service, and the dream of interplanetary logistics becomes reality. Thank you so much for sticking with me through this deep dive into Flight 9 and all its game-changing upgrades. If you enjoyed this breakdown, don't forget to hit like and subscribe. Your support makes these videos possible. If you're hungry for more, check out our video on the first orbital test of Starship Gen 1, where we walked through every nail-biting moment of that historic launch. You'll find the link right here or in the description below. Remember, spaceflight isn't just about rockets and regulations. It's about human curiosity, innovation, and the thrill of pushing boundaries. By watching, sharing, and chatting in the comments, you're joining a community of explorers who believe in the power of discovery. I'd love to hear from you. What part of Flight 9 excited you most? The beefed-up steel hull, the soft landing test, or the FAA's bold approval? Drop your thoughts below, and let's keep the conversation alive. Thank you again for watching. Your time means a lot, and I hope today's video left you feeling inspired and a bit more connected to the frontier of space exploration. Until next time, stay curious, stay hopeful, and I'll see you in the next video.